Just setting the mood up. Okay, now I'm ready. Hopefully you guys can hear me. This is your Systems of Inequalities flipped classroom. Today we have one guest. I have my guest here.
I'm Sam Flynn. My real name is Isaac. That's my secret code name for fun.
It's not secret if you tell them it's secret. You should just stick with Sam Flynn. Anyways, there's no cuts in this.
It's not Isaac.
Okay.
It's Ian.
We're going to go to systems inequalities. The key thing for us to understand the systems requires two or more. We're going to start nice and easily before we go on to other things. For example, let's look at this problem right here. Well, we're looking at ringtones. Ringtones, in this instance, it says you want to buy at least 6 ringtones from a website, and you cannot spend more than $15. How many premium ringtones and how many top 10 ringtones can you buy? And that suggests that there's 2 different prices, right? The premium ones are $1.50, and the top 10 are the $3 because they can charge that, and you would kind of introduce certain things like that. Setting it up is probably the hardest thing, and then we can go from there. Here we go. For those that don't know, Sam Flynn is otherwise known as a beloved character from Tron Legacy, shown and depicted below. And obviously, Sam Flynn's voice sounds a little bit more young currently. Let's go ahead and go with example number 1. Example number 1, I want to suggest that you do need to have a graph sheet of paper. Feel free to print one off, or you can go ahead and graph it manually. I recommend you not create the lines on your notebook because it creates, it actually makes it kind of inaccurate. So here we have a situation where there are a couple different linear inequalities here set forth here. Let's label, you got the red and then you have the blue. And what we're going to do is we're going to go simply with the red. I want to remind you when you graph the red particular one, let's go ahead and color code that with something a little bit more obvious. We have y is equal to 2x minus 3. I want you to go ahead and graph something like that. Stick with the xy coordinates. And then we'll have something like this, where you input any variables or any values as such. And then we have something like that where we substitute it in, and then we'll get, hopefully I don't get this right in front of you, or wrong in front of you, and that is -5. And then we have -3, and I'm guessing it's -1. And then you're going to plot this. Now, is it going to be open? Not open, but is it going to be dotted or solid? Awkward pause. Hopefully you have the answer within your head and you know that it's going to be dotted, ladies and gentlemen. So it's a dotted line, whereas over here it is also dotted. Go one line at a time. I'll give you a brief moment to do that on your graph. This long pause is for Bella. I think that's 7 seconds. If you look right now, I have a graph that's already completed. Now I have y is equal to 2x minus 3. Now, next thing you want to do is you definitely want to be able to test the mode in terms of shading purposes. So we know it's going to be y is less than, I think, 2x minus 3. And you want to test my trusty old 0, 0, and 0 is going to be less than -3, and that's a correct statement. So it's going to be shaded in terms of that area. Or you realize that I had actually made a mistake, and it's actually, y is actually, or not y, but 0 is actually not less than -3 because -3 is clearly less. So it should be shaded in this region, but I'm sure you all knew that when I made that mistake. So now you see my graph being shaded wonderfully in red right here. And you can see that the line is also dotted if you haven't realized that. So it brings me back to my next point, and that is simply that you have to be able to graph the next line. Now again, you notice that it is in standard form. So standard form, you have a couple different options with this. You can go about it with ye and she, okay? Or you want to some people like to just convert it back to slope-intercept form, which would be -2x is added to 2. It is your call, but I want you to go ahead and graph that. And here I have my line where it's drawn right here, and I don't know what it is as far as testing it, so I'm going to test 0, 0. And in this particular situation, I know I already have shading that exists, but I'm going to show you the graph on what it looks like without it shaded. focus on the math element, and then everything else will work. You know that 2 is going to put in with 0 plus 0, and it's equal to 2. And I think the inequality is greater than in this instance. So then, therefore, I know that it's going to end up being 0 is greater than 2. And I know that I do not include. Now, I do not include that. So therefore, I am shading the other direction. Okay. Now, this is where it's kind of easier for me to show through this program or this website. I do not want you to use this website for the sake of the fact that you need to learn how to do it manually. Once again, I will be teaching you how to use it with your calculators in a bit, but it's not going to be the case right now. So let's go ahead and do that. I'm going to enable the first shade, which looks like that. And then you're going to end up shading this direction, because what happens is it's going to be a result of it being greater than. And now you can see that there's a shading battle going on. I want to mention that the fact that this shade and this shade, they are part of the inequality. However, it is not the solution. The solution technically is where the overlap occurs. The overlap shown by my highlighting portion right there is technically where the answer is, because you have to look at the parameters or the limitations set forth within each inequality. So the answer technically is the overlapped area. So you take a look, and this is kind of what I graphed. Notice the dotted line is there, and the overlap technically is where it's at. For all intents and the purpose of this homework, I do expect to see all the fully shaded areas. In other words, I do want to see the partially shaded areas that I'm looping right now, and I also want the darker shaded region. Now, I want to emphasize the fact that I do not want you guys to shade in too hard. If you have the overlap area, you can shade in a little bit darker to show that the answer is clear. If you go on to the next one, there's a got it, and I expect this to be done. Go ahead and graph this and take the time to do it, and you can press pause, the Bella pause. Let's go on to the next portion. This next portion right here, where it's problem 2, is kind of the reverse, where we give you the graph, and the graph, you kind of have to figure out what the systems of inequality is. I'm going to have you focus on one at a time. I repeat, one at a time. So the first thing that you notice right here is the fact that there's a red line and then a blue line. Let's go ahead and go with the red line first. Want to remind you, with this red line here, you want to focus on 2 points. So you want to be clear in terms of what 2 coordinates you want. For example, most of the time you'll see that right there, it's going to be, I guess it's 1, 2, 3, 4, 5. So we have a 0, 5 point, and another obvious one we shall include maybe the intersection, which is basically 4, 3. You want to find the slope of that line. I do the L method. 5 minus 3 is 2. 0 minus 4 is negative 4. So now we have a negative slope. So I know my equation is going to be y is equal to negative 1/2 x plus b. Oh, but we know b, don't we now? So therefore, I can just go ahead and eliminate that, and that's 5. In the instance that I do not know b, you can substitute one coordinate into the equation to solve for the b. But lucky for us, we know this already. Here we continue. We have that one equation, and then we know that's going to be shading the yellow portion right here. It includes the point of origin. So therefore, if the point of origin, we want the statement to be true, so we're going to put it 0, and then we're going to leave that blank, and this is going to be gone at 0. So we have to have that as a true statement, so we have to go less than. So if my first equation then technically is going to be, and if I write a little smaller here, that is y is less than negative 1/2 x plus 5. Let's take a look right here. Now let's go to the blue line. Blue line, once again, we want to hit the coordinates. We know that we have 4, 3 is a common one. And then I like that one right there. Or you can even choose this particular coordinate right here. Let's go with that one. And that's be 1, 0. Find the slope. We have 3 over, that is 3 over 3, which ends up being, oh, I don't know, I'd put negative 3. Ends up being 1, so we have y is equal to x. And we know the intercept is shown here, and that's a minus 1, so we can go ahead and cheat by going ahead and write down that x is negative 1. Where is it shaded? We look at the blue is facing that way. Does it include the origin? That is an affirmative. Okay? So then we want to go ahead and continue on by, let's see, double check it. Y is equal to x minus 1. If it's y is equal to x minus 1, I'm putting in 0, 0 into the equation. And now we have 0 and negative 1. And we want to fill in a true statement with the origin in there. Therefore, it is going to be 0 is greater than negative 1. So hence my equation now is y is greater than x minus 1. And again, I want to emphasize that this area that I'm kind of scribbling over is the actual answer for the systems of inequalities. But I do want to also note that I don't want to forget about the fact that this is a solid line. Therefore, I have to consider putting the y is greater than or equal to x minus 1 line. Let's take a look what the answer is. And the answer, what do you know? I got the right answer. But notice that even the book suggests that you want to focus on the equation without the inequality. Let's move on to the next one. And hey, there's a got it. I want you to take the time to do this and work it in your notebook. I am going to be looking to see if the work is shown as far as going with each line and then also testing it in with the test point. So make sure you have that. When I randomly check the notebook, that would be something that would count for points. The Bella pause. Now we've reached the next section where I kind of need you guys to work on some things. There are 3 questions. I see that. If you print it out, I only put 2 graphs because that allowed me to show the graphs. I would just erase it. I want you to do 10, 11, 12, and go on to do 22, 23, 24, 25. This will be the basis of our group discussion that we have during class. And that concludes our short mini lesson today, and I appreciate the patience. This is Mr. Lowe, and I guess Sam Flynn kind of disappeared. We are out. Have a great one, and be good on their MSI field trip.